So to pick up where we left off with log functions, what we're going to look at next is a particular type of log function that involves what's called the natural log. So if you remember when we were talking about exponential functions, the second part of the lesson that we did with that, we got into looking at a special type of exponential function, which is what was known as the natural base. So the natural base, which is y equals e to the x power, has an inverse function that's what's called the natural log function. And it's read, it has a special symbol here, and this is lnx. And I'll show you where this is on your calculator, but sometimes that's referred to as the natural log of x, or sometimes it's referred to as the ln of x. So the function most notably is called the natural logarithmic function, or the natural log function. And here is just a side-by-side comparison of, here is the graph for y equals the natural base to the x power, which we talked about when we did some different things with exponential functions, and here is the graph for the natural log function. Just notice once again, because they're inverses, they are symmetric to the identity function there. So that's just some different things as far as the graph for that goes. So as far as some properties go, we have here first the natural log of 1 equals 0 because the natural base to the 0 power is 1. Just remember, anything to the 0 power is always going to equal 1. Second property here, the natural log of the natural base equals 1 because the natural base to the first equals the natural base. Anything to the first power just equals itself. And then there's an inverse property here that's involved. So just keep in mind that because the natural base and the natural log are inverses of each other, whenever they're coupled together in the same expression, they cancel each other out. So for instance, if I were to take the natural base of the natural log of the natural base of x, those two values, because they're inverses, are going to cancel each other out, and I'm just left with an x. Same thing if I did the natural base to the natural log of x power, these are going to cancel each other out, and I'm just left with an x there. Those are just two inverse properties. And then the one-to-one property that's shown here, if the natural log of x equals the natural log of y, then simply x and y must both be the same. So as far as just some different examples involving your calculator and kind of showing you where the natural base is on your calculator. So if I'm going to do y equals the natural log of x, so for part A, I have x equals 2. So I'm going to use my calculator and I'm going to take the natural base of 2. And what I'm asking myself here when I do this is e to the what power equals 2. The natural base to the what power equals 2. So when I do this here, and I'll show you first, if you notice in your calculator, right below the log button is the natural log button. So if I do the natural log of 2, I get a value of 0.6931471,806 because e to the natural base to the 0.693 power equals 2. So that's for part A there. For part B, I'm going to take the natural base of 0.3. So I'm going to do here the natural base of 0.3, and I get negative 1.20, because if I were to do the natural base to that power, I would get a value of 0.3. So that's for part B. For part C, I'm going to take the natural base of negative 1. So when I do that, I got the natural log of negative 1. So if I do that here, notice I get once again an imaginary solution for this, because remember, I kind of come back to this again. What I'm basically asking myself when I do the natural base of negative 1, I'm asking myself e to the what power equals negative 1. So because this base is positive, there is no real number that exists that I could take to that power that's going to get me a negative answer for this. So that's what's doing with part C there. And then for part D, if I did the natural base of 1 plus root 2, what I'm really asking myself here is e to the what power equals 1 plus the square root of 2. So if I exit out of here and I do the natural base of 1 plus the square root of 2, that's the value that I get there, because if I did the natural base to that power, I would get a value that's equivalent to 1 plus the square root of 2. So if I just put in 1 plus the square root of 2, just to kind of show you this here, notice that those are the same. So that's just some different things with the natural log involving your calculator there. So you kind of move to the next example, and this has more to do with the properties. So the question here says, use the properties of natural logarithms to simplify each expression. So if I have this here, the natural log of 1 over the natural base, remember that I can take this and rewrite it as the natural log of the natural base to the negative 1. So anytime you couple the natural base with the natural log, those are going to cancel each other out, and what I'm left with here is just an answer of negative 1. And this is actually something you could just type right in your calculator and you would get the answer for that there too. So that's part A. For part B, once again, notice I have another inverse property here. If I take the natural base and I take it to the natural log power, those are going to cancel each other out, and what I'm left with here is just a 5. So that's the answer there. For this one here, the natural log of 1, remember what I'm asking myself here for the natural log of 1, I'm basically saying e to the what power equals 1. So just remember that anytime you have an exponential function that equals 1 at the end, that makes the exponent equal 0 every single time here. So that makes the natural log of 1 equal to 0, and 0 over 3 is simply just 0. So that's the answer for part C. And then for part D, notice once again I'm taking the natural base and the natural log and I'm coupling them together. They're going to cancel each other out, and what I'm left with here is just a 2. So that's the answer there for part D. So in terms of some different things with the natural log, just keep in mind that we looked at the natural base as sort of a special type of exponential function, and we're kind of looking at the natural log as also a special type of exponential function as well, because both of those values have their own keys on the calculator. So just make sure you notice the relationship between those two, because those are going to be very useful for what we're going to use when we start to get into looking at solving exponential equations and also solving log equations.